All right. Can everyone see my screen? Excellent. Okay. Good morning, everybody. Today we are so excited to share with y'all our final presentation for our Blue Devil Bridges project. Before we jump into things, I'd like to give my teammates a chance to introduce themselves. I'm Latham Hall, and I'm studying computer science and visual media studies here at Duke.
My name is Claire, and I'm majoring in computer science and statistics.
My name is Jason. I'm studying computer science and finance.
My name is Catherine. I'm studying computer science and electrical and computer engineering.
Thanks, guys. So for those of you who might not know, Blue Devil Bridges is a one-to-one mentorship program that matches Duke undergraduates with Duke alumni. Duke Student Government worked alongside the Office of Alumni Engagement and Development and the Career Center to launch the pilot for this program in November of 2023. It works by having students and alumni fill out separate Qualtrics surveys, which include questions about demographic information, academic life, career aspirations, and other interests. The survey responses are then run through an algorithm to create mentor-mentee pairings. Ideally, the algorithm would generate 100% of the pairings, but of the 1,200 pairings last year, only about a third were made by the algorithm. This left over 700 pairings that had to be manually matched, which is a very time-intensive process and not the most ideal. So that was one of our tasks for this summer, to decrease the number of manual matches that needed to be made down to 0. We actually ended up breaking down our goals for this summer into 4 main categories. First, we redesigned the survey questions and overall general data collection process. Then we developed a scoring algorithm that determined the quality of a mentor-mentee match. And we took those scores and developed a new matching algorithm to determine the one-to-one student-alumni pairings to maximize the number of high-scoring or good matches. Finally, we designed a website for the administration to use that we think is very pleasant and easy to use, so that the algorithm isn't just a Python file that's run on someone's laptop. All right, so like I said, the first step was to redesign the survey questions and rethink the overall data collection process. Our first step was to go through the survey questions to figure out which were absolutely necessary for creating quality match. The goal was to make the survey as concise as possible and to avoid asking any unnecessary questions. Last year, there were a few survey questions whose responses were not taken into account by the algorithm, such as questions about location or some identity questions. So it was up to us to determine if these questions were important enough to include and how to incorporate their responses into our new scoring algorithm. What we ultimately ended up doing was changing the location question to focus on the top 21 locations with large populations of active Duke alumni. And we also merged some of the identity-based questions into one bigger question, which made it simpler for us to incorporate the responses into our algorithm. There were also some redundant questions on the original survey, which we worked to combine in order to have fewer questions overall. The goal was to collect as much data as possible while having as few questions as possible, so we had to walk a line there and find a happy medium. And then finally, we adjusted the general question format for the surveys. Last year, many of the questions asked participants to select all that applied, which led to some participants selecting all options, which made it really difficult to create good matches. So we changed that to be select up to 3 so that we could force participants to prioritize what's most important to them and hopefully generate higher quality matches. We also made changes to the final question, which you can see here. Last year, there were 8 matching criteria like industry, hobbies, identity, etc., and participants ranked them 1st through 8th based on how important it was for their mentor or mentee to share that quality. We adjusted this to have participants rate each category on a scale from 1 to 10 to allow for more flexibility with that. Also, alumni might not want to fill out the same survey every year, so we are working on a way to save their previous survey responses for them to just scan over and resubmit every year so they don't have to fill out the entire survey from scratch. That's it from me. I am now going to pass it over to Claire.
Yeah, so then we spent a good amount of time rethinking and redesigning a new scoring system from last year. And our overarching goals were to generate a matrix of similarity scores between all possible mentor and mentee matches to then be fed into our matching algorithm. Specifically, we wanted to take into account similar responses in addition to responses that were exactly the same to introduce more nuance. And we also wanted to weight categories based on participants' individualized preferences. Each one of these overall similarity scores is calculated using multiple components of data that we collect from the survey. So, for example, academics, industry, post-grad location, desire to go to a certain graduate school, and more. And like Latham mentioned, on the survey, participants can select on a scale of 1 to 10 how much each factor is important to them, which would then affect the weighting of each of these subscores in the final calculation. In order to do this, each question actually has an associated matrix that relates all the possible responses, so we can evaluate how similar a mentor and mentee's responses are. This is a huge difference from last year, because last year, if the mentor and mentee had the exact same answer to a question, then that would boost their score. But otherwise, the score just wouldn't change at all. So we think that adding these scores for each question would introduce more nuance into the equation. If we take a closer look at the 3 questions that go into the final academic score, so major, minor, and certificate, we calculate the academic score by weighting each one of the categories based on their relative significance. So here we would weight major as with a weighting of 1, and minor and certificate score with a weighting of 0.3. Depending on the nature of each question, we implemented different types of scoring. So for majors, minors, and industry, we employed semantic similarity using pre-trained natural language processing machine learning models to generate those similarity scores based on how closely 2 phrases were related. We used geographic proximity for comparing post-grad locations, and for other questions, we retained the 1-to-1 exact match scoring because we felt like each response was very different, and pairing those similar responses wouldn't yield much additional value. So here's a closer look at semantic similarity and why it introduces more nuance. So as you can see, exact matches still have that high score of 1, but similar matches, so for example, a computer science and an ECE major would be more likely to be paired than, say, an ECE and an art major. So now I'll pass it on to Catherine to talk about our matching system.
Thank you, Claire. Our next step is to design a new matching system. We want to create a system that matches mentors and mentees based on the scoring matrix from the scoring algorithm. Here are some goals we have. First, it gives everyone a match. And second, it achieves the highest possible total score for the pairs it matches, optimizing overall satisfaction from both sides. Lastly, the runtime should be very efficient, and we successfully reduce it to less than 5 hours for about 1,000 plus pairs so that it will be easier and quicker for the administrator to use. We have been looking into one of the advanced variations of Hungarian algorithm, which solves the problem by finding the optimal 1-to-1 matching, that the sum of all scores are maximized. The mechanism behind the Hungarian algorithm starts with transforming the scoring matrix to ensure that each row and column contains at least 1 0. This is done through multiple rounds of row reduction and column reduction and optimal assignments. We have also designed the rematching process without compromising satisfaction. So the reason we want rematching was because based on last year's data, the number of alumni and students signing up are different, and we want everyone to be paired. Therefore, in our algorithm, we detect if the number are even. If not, then after the first round of matching, we check for alumni data and get a list of alumni who are willing to take more than 1 student. Additionally, the algorithm filters the pair with similarity score lower than the threshold value we manually set. We put those alumni and students into 2 lists and run the scoring and matching algorithm again. So ideally, maximum number of participants from both sides are matched to ensure their engagement and experience. Now I'll pass it to Jason.
Yeah, so in addition to building the algorithm, we designed a dashboard that administration can use to run the algorithm and collect data, making the process more user-friendly. Here's the dashboard prior to running the algorithm. Authorized users will be able to access this page after logging in using their NetID. Users will be able to upload the 2 CSV files from the surveys and run the algorithm. After the algorithm finishes, the site will just After the algorithm finishes, the site will display a button to download the CSV file containing the mentor-mentee pairings. Additionally, you're able to immediately view a histogram outlining the quality of statistics and basic statistics from pairings such as the average similarity score. This is the statistics dropdown. Here, administration will be able to view the analytics from the most recent iteration of the matching algorithm. These pie charts will be dynamic, displaying key data points. Finally, here's the past matches dropdown. This tab will provide records of all past iterations of the matching algorithm. Here, they'll be able to download the CSV files containing mentor-mentee pairings, load the statistics onto the page, rename the iteration, and delete the iteration. Here's a demo of our website. Hello, welcome to the demo for the administration website for the Blue Over Bridges mentorship program. My name is Jason, and I'll be showing you how the website works, as well as the features included. Here's the page you're first taken to. This is where you'll run the mentor-mentee matching algorithm. I'll first upload the survey results from the potential mentors and mentees. These results are collected through a Qualtrics survey and are exported as CSV files. The website will make sure the CSV files are formatted correctly before it allows you to upload them. That's why there's an alert that pops up letting me know that these files are acceptable because they've been formatted correctly. After the files are accepted, I simply just need to click the start pairing and the algorithm will start. This alert gives me an estimate of how long it'll take to run. In this case, since there are over 1,000 mentors and mentees, it'll take about 4 hours to process. While this is running, I can't close my laptop nor the page, or the algorithm will not be complete. As you can see, if I try to close the tab, it'll stop me. Well, I guess I'll see you guys in 4 hours after this finishes. Alright, so 4 hours later, this is what it looks like if the pairing has been done. As you can see, there are immediate base level statistics from the pairings, including a histogram of the similarity scores between the mentors and mentees, as well as the average, maximum, and minimum similarity scores. There's also a new statistics tab that pops up. Here, you'll see 2 more key data points from the iteration, including the distribution of student years amongst the mentees and the distribution of graduation years amongst the mentors. In the past pairings tab, you can see that there's a new iteration that appeared after I ran the algorithm. I'll go ahead and rename that demo iteration. Finally, if I click View Pairings, the website will export a CSV file onto your laptop containing the pairings from that iteration. So that's how the administration website for the Blue Over Bridges works. I hope you all enjoyed. I'll now pass it to Claire to talk about our workflow.
Our workflow behind our website falls into 3 main components: data collection, the front-end website located on our server, and our database. So as discussed before, data collection is done through Qualtrics, and responses are then formatted in Excel to ensure that they meet the requirements to be inputted into the scoring and matching correctly as CSV files. When the CSV files are uploaded, they're fed into the algorithm and also saved to the database under student records and alumni records. To access our website, users are first led to the Duke NetID authentication page before they're brought to our homepage, so we can make sure that only the right people have access to our site and the information on it. After scoring and matching is complete, a results.csv file is outputted containing pairings, and the pairings are also saved to the database. To view statistics in past pairings, the website then pulls entries from the database. Here is our tech stack. To build the website, we use HTML, CSS, and C# with Blazor, a .NET front-end web framework. For scoring and matching algorithms, we use C# and Python libraries like PyTorch and Transformers for the pre-trained natural language processing models. I'll pass it on to Latham to talk about next steps.
All right, so while Code Plus may be coming to an end, we do have some plans to continue working on this project. We are currently discussing applications with the Blue Devils Beyond team, which is based in New York, and they connect recent Duke graduates with older Duke graduates in the city. The program's set to launch mid-September, and some of us are working on helping that happen. We also have some ideas for improving the Blue Devil Bridges program, such as allowing users to specify pairings that they want to happen before running the algorithm. And we'd like to integrate it with the existing alumni database so that we can store updated alumni info, just make that all one streamlined process. And then we absolutely could not have done this without all of the incredible support from everybody involved in this project, from our team leads to Duke Student Government, our sponsor, Kent, and our stakeholders from Duke AD, as well as all of the amazing people with the Code Plus team. Like, thank you. We are so grateful for everything y'all have done.